Hello dear students, today we are solving the ISI JRF Economics 2024 paper. This is question number 2 which I am going to solve. This has around 4 parts, 25 marks, big question. Okay, here we go. Consider a monopoly is facing two consumers A and B, and all agents have two periods, 1 and 2. The beginning of the period 1, the monopolist holds stock of the 2 units of the goods which doesn't depreciate and last indefinitely. In their lifetime, each consumer has consumed at most 1 unit of the product. Therefore, if a consumer buys the product 1, she can use it for 2 periods, but if she buys the product 2, period 2, then she can only use it for period 2. Okay, 1 period only. So notice that the monopoly's marginal cost of supplying goods is 2 units, is 0, and holding cost. Let the money value as per as the benefit of the using 1 unit of the product V and VV and the product A and B respectively. Assume VA greater than VV. The monopolist knows that VA is greater than VV but cannot distinguish between the consumers on the basis of the valuation, since two consumers cannot be charged different prices. Suppose that the consumers the monopolist rents out product to the farms of one product only at the end of each period. RTB, the per unit rent charged by the monopolist for the period T1 and 2. Find the profit maximizing values of R1 and R2. Find also the corresponding total discounted profit of the monopolist. So renting it out T1 T2 period 1. So monopolist profit is given by profit 1 is R1 1 by VA plus VB. Period 2, consumer A rents product 2, then VA into sigma and VB into sigma. So here profit in this 2 is R2 So to maximize the total discounted profit, we need to maximize the sum of the discounted profits over both periods. So pi equal to substituting pi 1 and pi 2 in these two formations. So pi is plus VA plus VB square, taking the first order conditions with respect to R and R2 and setting it to this. So del pi del R1 to 1 plus sigma square equal to 0 square equal to 0. So we find out that R1 equal to and R2 equal to this value. So substituting these values into the expression for the total discounted profit, we get that square. This is the first part done. Now suppose that the monopoly is forced to sell only in period 1 the optimal price charge. Find the corresponding monopoly profit. So PV, the price charged by the monopolist for the product in the period 1. In this case, monopoly sells the product to the consumer who values it the most, which is consumer A. So P equal to VA only, pi equal to P into 2, P2 minus 0, so 2 VA. Next, suppose that the monopolist can sell either the product but must pre-commit to the period specific prices. Thus the monopolist declares the prices for the period P1 and P2 and beginning of the period 1 and cannot give change afterwards. So VA greater than, suppose this thing, so as a part of the Nash equilibrium we have to form. So the total discounted profit in this case it will be uh, so VA greater than 2 of VB is given. So the monopolist will sell to consumer A in both periods if the prices are such that PB. Okay, so therefore the total discounted profit in this case will be pi VA into 2 plus sigma plus VB square. Okay, so let's go for the fourth part. Suppose that the monopolist can sell in either period but cannot pre-commit to the period specific prices. Thus the monopolist declares that the price at any period T and PT only at the beginning at the particular period. So in each period the consumer choose whether to buy in that period. So again VABB. So explain intuitively two period price combination that maximizes total profit and Nash if not identification. So P1 equal to VA and P2 equal to VB. So P1 equal to VA in period 1 and period 2. So the monopolist chooses, he gets like pi equal to 2 VA. VA plus B. So the price combination cannot be sustained as a part of the sub-game perfect Nash equilibrium because monopolist charges P1 equal to VA in the first period 1 and consumer will buy. Then in period 2 if the monopolist charges P2 equal to VB, the consumer will not buy because of the valuation is less than in this period. So to find the combination in period 1 he will do it is exactly the opposite VB and period 2 he will do it as VA. So the combination maximizes the total discounted price and can be sustained as a part A sub-game perfect Nash equilibrium. And that's the end of this question.